Hi there, folks. This is the practice for the final exam, and as always, I am the amazing Mr. Jansen, so away we go. If we look at this first one, it asks us to convert these degrees to radians, and I'm just going to use a little bit of factor label for this. So I start off with 125 degrees, and I'm using my factor label. Remember that degrees and radians, the conversion here is that there are 180 degrees for every pi radians. Right? So that's my conversion. I just make sure my units line up so that the degrees cancel out. And so now what I end up with is 125 pi over the 180. And then really it's just a matter of reducing this fraction. So I've got to reduce the 125 over the 180. And it looks like that reduces to a 25 pi over 36. And that's it. If I look at the next one, it asks me to convert this to degrees. Well, I'm going to do the same thing. I'm just going to set up some factor label here. So I've got this in terms of radians. So I need radians to degrees. Every pi radians, there's 180 degrees. And so what happens here is my units cancel, my pi's cancel. I just have 5 times the 180 divided by 3. And it looks like that gives me 300 degrees. And that's it. Okay, so we're just using a little bit of factor label. For this one, it asked me to draw a negative 35 degree angle. And this doesn't have to be super accurate. I just want to determine what quadrant this thing is going to be in. So remember, I always starting position is right here on my x-axis. And if I want to count negative 35 degrees, it means I'm going to go clockwise. So 35 degrees is right around in here somewhere. So that would be my negative 35 degree angle. And then to list one coterminal angle, really all I have to do is take the negative 35 degrees, and I have to add or subtract multiples of 360. So an example would be just adding 360 degrees. And essentially what that does is it takes me from here around the circle one more time and lands me at the same spot. Okay? So if I add the 360 degrees, that's going to give me a 325 degrees. That would be one option. I could also do negative 35 degrees minus 360 degrees. And essentially, that's going to take me back around the circle going this way and back to that same angle. Okay? So whether I add or subtract, it's still going to essentially give me the same thing, just a different way to express a different coterminal angle. All right? And that would give me a coterminal angle of negative 395 degrees. Okay, so any one of these would work, and I could add another 360 to either one of these or subtract another 360, and you give me another coterminal angle. So there's plenty to choose from here. And the next one is asking me to find the arc length and the area of the sector. And remember, the arc length is just a piece of our circumference. So I set it up kind of like a ratio here. So if you think about the circumference is 2 pi r. So the circumference of this particular circle is going to be 2 times pi times 5, which is essentially 10 pi. So now if I set up a proportion here, basically I'm looking at a piece of that circumference. So I compare it to the degrees here. Right now I've got 75 degrees over the 360 degrees total. That's the same thing as whatever that piece is, so this piece that this guy covers, over the total, which is 10 pi. Okay, so I do the piece that I'm looking at is 75 degrees, over the total circle is 360 degrees. The piece that I'm looking for, which is x, over the total circumference, which is the 10 pi. And now essentially I just cross multiply and I solve. So here that's going to give me 360. I can get rid of the degree symbols. I don't need those. So I've got 360x equals 750 pi. And then I just divide each side by the 360. And I'm just going to go ahead and round this off. And if I round it off, it's going to be approximately, let me extend that a little bit, x is going to be approximately 6.54 units, whatever those units happen to be. All right? In terms of the area of the sector, I essentially do the same thing, except I use area. Area is pi r squared. So I've got pi times r, which is 5 squared. So I've got 25 pi. That's my area. And I just want a piece of that area. The piece is represented by 75 degrees. So the portion I'm looking at is 75 out of 360. And I want to know how much that is out of the 25 pi. Okay, so again, the piece I'm looking at is 75 degrees over the total. I want to know the piece, which is x over the 25 pi. And then again, I just cross multiply 75 times 25. And now I'm just going to divide each side by the 360. Once again, I'm just going to plug this into my calculator and round it off a little bit. It looks like it gives me about 16.36. I'll round it off there. And that's my area of the sector. All right. So I'm just setting up a proportion, the degree versus the whole thing compared to the circumference, the degree versus the whole thing compared to the area. All right.
Number 5, it says decide if the sequence is arithmetic or geometric and find the next two terms. So really we're just looking for the pattern here. In this one, it looks like I'm subtracting 6 each time. So if it's going down by the same value, I'm adding a -6 each time. That means this thing is arithmetic. So this one is arithmetic. And if I want to find the next two terms, I just subtract 6 again. That gives me a 32. I subtract 6 again. That gives me a 26. And that's it. Okay, so it's arithmetic. And those are the next two terms. For the next one, we want to decide the same thing. And really, it looks like I'm dividing by 2 each time here. So really, I'm multiplying by 1/2 each time. And since I'm multiplying by the same thing each time, it means this one is geometric. And if I want to find the next two terms, I'll just multiply by 1/2 again. That's going to give me a 3/2 and then a 3/4. And that's it. Those are my next two terms. Okay? For these, it says use the following formulas to answer the questions. So we're just going to have to decide which formula we're going to use and plug the stuff in. Number 7, it says find the 13th term of the sequence. Given a sub 1 is 7 and d equals 3. And really, since they give us a d value, I know we're talking about an arithmetic. And we're not talking about a sum, so I just want my plain arithmetic sequence formula, which is this first one. So I'm going to do a sub 13, because I'm looking for the 13th term, equals a sub 1, which is 7. Plus n, which is 13, it's the number of the term I'm looking for, times d, which is 3. And I just have to simplify this. That's 7 plus 12 times 3. So that's going to be a 7 plus 36. So I find out that the 13th term looks like it's going to be a 33. Sorry, a 43. Let me try that one more time. 43. There we go. And that's it. On this one, it says S sub n, so right away I know I'm looking for a sum. They also give me a d value, which means this thing is arithmetic. So I know I'm using this second formula. That's my sum of an arithmetic series. So S sub n, so I'm looking for S sub 20 equals 20 over n, which is, over 2 from our formula. And then a sub 1, which is 7 plus a sub n, but I don't have a sub n. They didn't give me that, which means I need my other arithmetic formula. So I'm looking for a sub 20 this time. A sub 1 is the 7 plus n minus 1 times d, which again is the 3. Okay? So now I've got to plug this in. Once I find this, I'll have my a sub n, which will go here. So now I've got to plug this in. That's 7 plus, that's going to be 19 times 3, so a sub 20 equals 7 plus, let's see, that's going to be a 57. So this is going to give me a 64. So now I'm just going to plug this into my calculator. I've got 20 equals 10 times. 7 plus the 64 is going to give me a 71. And now when I multiply, that gives me 710. And that's it. All right, so if you're missing a piece from the formula, you might have to go use another formula. All right.